In this lecture, we're going to continue with nomenclature, and this time we're going to specifically focus on acids. Your objectives here: understand acids that have hydrogen in them, identify the parts of acid formula, and then just like with ionic, be able to write chemical formulas and names for acids. Now, all acids are made out of non-metal only, so it makes them kind of a special category, and you see it's because of the way they work. Acids are made of non-metals, but they act like ionic compounds. They're always going to combine hydrogen, and notice one of these has just one, the other has three, and they're going to use hydrogen as the cation, and then they're going to combine it with some anion to achieve a net charge of 0. As I already said, all acids contain hydrogen, and it's usually going to be at the front of the formula. We're going to try and be very consistent with that. Now, I say usually because we will be consistent in the classroom, but if you branch out, watch other lectures, go online to look up formulas, you might see, oh, hey, that doesn't really follow the rule, and you've got to know these well enough that you can use the rule correctly, because for class, I want to see them done this way with hydrogen at the front. So it always puts it at the front. It's going to act as the cation, because it's acting like an ionic compound, and it's got a charge of +1. Hydrogen always has a charge of +1. So it is in that first column. It is a non-metal, but when it's in acid, it acts like an ion. Its charge is +1. It's in that column. The anion can either be just one element, as we see here, just chlorine, or it could be a polyatomic ion. We've got phosphate on this other one. Acids are usually dissolved in water, and it causes what we call an aqueous state, and that is shown here with AQ in parentheses, and we do want to include that right next to the formula for acid. So we always, and you'll see, I might trip up and forget these two, but we really want to get to the point where we're consistent, and we always include that AQ to show that it's the aqueous acid. Now, when we get to formula and naming, the chemical formula is going to be balanced the same way as ionic compound formulas, but with the name, and the formula and the name, it all kind of blends together, and you're going to see when you try and go back and forth between the two, but it's the anion that's really going to guide the name of the acid. And this chart already starts to show that. All of these ions in the left column are anions, and that should immediately click because you can see that they are all negative. So the first naming rule is if the anion name has "ide" in it, and remember all of those negative, those actually have a slight name change with "ide." Fluorine becomes fluoride, chlorine, chloride, oxygen, oxide, nitrogen, nitride. When it ends with "ide," so we're really focusing on the anion, the name is going to attach hydro at the front, so you're going to have the prefix, and then it's going to put "ic" at the end, so the "ide" drops off and becomes "ic." This piece becomes "ic." Hydrofluoric acid, so we had fluoride, fluoric, and we have hydro at the front. Nitride. Now, nitride has a charge of 3-, and we can see that the formula is balanced, H3N, and that name is hydronitric acid. I've left 2 for you to do on your own. Go ahead and pause the lecture, follow these rules, try your best to fill in the rest of the boxes, and then come back to see how you did. The bottom 2 rows here are filled in. S2- is sulfide, gives us H2S, remembering to put the AQ, hydrosulfuric acid. Then Cn-, it is a polyatomic ion, but it ends with IDE, so it does follow the rule here. We have HCN, because +1 and -1, and it's hydrocyanic acid. Now we have a list that's got some polyatomic ions, and we can see that the name ends with 8. So this first one is sulfate. You know that all of these are going to be names that end with 8. That's just this particular chart. We balance to make the formula. So sulfate is 2 minus. It's going to take 2 hydrogens, H2SO4, and again, remembering to include the AQ. The only change now is the 8 turns into ic. Notice there's no hydro at the front. So I'd added hydro and ic, but 8, you don't have hydro and you just want to change the ending to ic. I know it's going to take time and practice. I want you to pause the lecture, try and fill in the other boxes there for those 3 rows. And then when you feel like you've followed all the rules, turn it back on to see how you did. How did you do? We've got nitrate, and then we get nitric acid, HNO3 with the AQ. Phosphate gives us H3PO4 with the AQ. That's phosphoric acid. And then lastly, carbonate. So we see all of those 8s, and that gives us H2CO3, aqueous carbonic acid. So now we've seen ide, we have hydro and ic, 8 just becomes ic. The last one is if it ends with ite. So we can really see it's the anion because every formula is going to have hydrogen in it. All of these are acids, they all have hydrogen. That's the cation. The anion is the driving factor. So phosphite, PO3 with a 2 minus, and now we have H2, and I've got a little typo here. It should be a 3. So H2PO3, we have the aqueous, and there's no hydro. The ending is us. So ite becomes us. Phosphite becomes phosphorus. And there's a few of them that are tricky, like phosphorus and sulfur. Most of the others are pretty straightforward, because why isn't it phosphorite? I don't know. I didn't make it up. It's just how it is. So phosphite, but it is phosphorus acid. Go ahead and try the other 3. Follow the rule. Do the best you can. Remember to include the AQ, and then turn the lecture back on to see how you did. Nitrite, and we get HNO2, nitrous acid, sulfite, H2SO4, and it's sulfurous acid. So again, the phosphorus and the sulfur, they're kind of quirky with the ites, and then they put the back in. It's going to take some practice. And then hypochlorite, I thought it would be good to include one of those kind of unusual, we don't see it as often, but we might see it once in a while, hypochlorite. And so we've got HClO, and it's aqueous, and that, so in this case, this hypo, I mean, it's just still part of the name of the anion. So hypochlorous acid, we can see that the ite still just changed to us, and you're able to keep the rest of it the same, the hypochlor part. Okay, we're going to pull it together, and I just thought I would mix together a couple of formulas and some names, and you can see that the chart was really handy. It breaks it down, but basically on a test or any kind of work that you're doing, you're only going to see a formula or a name. And you have to go back to this idea of, okay, I'm going to focus on the anion. Is it ide, ate, or ite? How does that all work together? So it does take time to really figure it out. I want you to pause the lecture, work on these, and then when you think you've got all of your answers ready to go, turn it back on to see how you did. You have reached the end. So HClO4, that was perchlorate, so we have perchloric acid. Hydrobromic acid, because it has hydro at the front of the name, we know that we're going to use something that had ide, so I would use bromide. Chlorous acid, so it's got the us ending, which means I'm looking for something that had ite. So we've got HClO2, because chlorate's the most common, ClO3, so ite is one less. That gives us chlorus. I know it's a lot to remember. H3PO4, H3P, PO4 is more common. So that's just one element, and the one elements are always going to be ide. So we've got hydrophosphoric acid. And then I had to throw in acetic acid. That always confuses students. The ion is acetate. Notice you can write it exactly as it is on your list from the summer, and it was a -1. We know that H is a +1. So it's a very involved formula, but it still has just the two pieces of the H and the anion. The anion was acetate, and that gave us acetic acid. Alrighty, you're going to get more practice, and you'll have time to really work on these and get the hang of it. Good job.